friends, I am Dr. Nilesh Dani, working as a lecturer mathematics at Government Polytechnic Rajkot. We are in the series of lectures for Diploma Engineering students, second semester, and the subject we are discussing is Advanced Mathematics Group 1 and Group 2. Our topic of discussion is differentiation and its application, Part 8. Before this lecture, we have seen the concept of differentiation or derivative, formulas, various concepts and their examples. Also, we have seen one application of differentiation. It is maxima and minima. Before we start the next application, let us have a brief look on the revision or whatever we have seen so far. So we have started with the derivative, that is its definition, and we have seen some of the formula of standard functions and its derivative. These are x raised to n, e raised to x, a raised to x, log x, sin x, constant function, cos x, tan x, sin x, cot x, cosec x and sec x. Also, we have seen the working rule. These are the rules to get the derivative of addition, subtraction, multiplication and division of the function. These are the rules which is known as a working rule, which we have seen. We have also seen chain rule, that is derivative of composite function of two function or more functions. If y is a function of u, u is a function of g, then this is chain rule, that is dy by dx is equal to dy by du into du by dx. And also we have seen the derivative of implicit function. Implicit functions directly differentiated both sides with respect to x, and then we solve it for dy by dx. That is how we get the derivative of the implicit function. Also, we have seen derivative of parametric equation or parametric function, where function y is equal to ft and x is equal to gt. And y and x both are represented in terms of t. So we got derivative of y with respect to t, derivative of x with respect to t. We take a ratio, that is dy by dx. Then we have logarithmic differentiation, which is generally applicable where the base and power both are function of x. Before differentiating the function, we take log both the side and then we take it derivative. Then we have seen successive differentiation, that is differentiation of any function more than once, and that we only restrict ourselves to second order derivative in the as per our syllabus. Then we have seen one application to find the maximum and minimum value of the given function. For that, we find the root of f dash x is equal to 0. That is the point where the functions are either maximum or minimum, and then we check whether f dash x is less than f double dash x is less than 0. Then we can say the function is maximum, and if f double dash x is greater than 0, the function is minimum. Now today we are going to see one more application of differentiation. As we have seen earlier that any function y is equal to fx, there are two variables, y and x. X is independent variable and y is dependent variable. So here, if we have any change in x, we have a change in y. So derivative is a rate of change in y with respect to x. So whenever there is a change, there is a change in y. So we get a rate of change in y with respect to x. This rate is known as derivative of y with respect to x. As we know that whenever a particle or any object is moving, there is a change in its displacement or in position. So with respect to time, there is always change of an object in its position. So differentiation or the rate of change in displacement with respect to time is nothing but velocity. So velocity is derivative of distance with respect to time. And as we know that change in velocity with respect to time is a concept of acceleration. So the rate of change in velocity with respect to time gives acceleration. It means velocity and acceleration are derivative of displacement and velocity with respect to time respectively. So today's topic is on this velocity and acceleration as a application of differentiation. So let us see how we can get this. So velocity and acceleration, as we have seen, they are derivative of distance and velocity with respect to time. So we one by one see the what is velocity and what is acceleration with respect to differentiation. A moving object is satisfying the equation of motion, that is S is equal to f of t, where S is a displacement or a distance and t is time. So any moving object satisfy this equation, that is the equation of motion. This equation is known as equation of motion, as it is S is equal to ft, where t is time and S is distance. Now if I differentiate this S with respect to t, ds by dt is velocity. So velocity v is ds by dt. So it is a first order derivative of S with respect to t. Now acceleration, that is derivative of v with respect to t, that is the rate of change in v with respect to time. So it is an acceleration a, that is dv by dt, or we can say it is a second order derivative of S with respect to t. It is a second order derivative of distance with respect to t. Here S is distance, here S is distance, t is time, v is velocity, and a is acceleration. So there are four parameters we have, that is S, t, v and a. Here this first order derivative of S with respect to t is velocity, second order derivative of S with respect to t, or first order derivative of v with respect to t is acceleration. So if we know t, we can find S, v and a. So here we have function S, v and a in terms of t to get the appropriate value. Here we solve certain example of this. Now here we are given S as a function of t, that is equation of motion. So equation of motion of a particle is S is equal to 3t cube plus 6t square plus 5t plus 1. Here we are interested to find the velocity and acceleration. V means velocity, a for acceleration at t is equal to 1 second. So at t is equal to 1 second, what will be the velocity of this particle, moving object or moving particle, and what will be its acceleration at t is equal to 1 second. This is instantaneous velocity or instantaneous acceleration, means it is a acceleration or velocity at a particular time. Now first we differentiate this function S is equal to ft, that is equation of motion, with respect to t. So derivative of 3t cube is 9t square. Derivative of t cube is 3t square. So 3 into 3 t square is 9t square, plus derivative of 6t is 12t, plus derivative of 5 into t is 5 into 1, that is 5. So derivative of 3t square, 3t cube plus 6t square plus 5t plus 1 is 9t square plus 12t plus 5. Now we find a, that is dv by dt. So derivative of this function 9t square plus 12t plus 5. So derivative of 9t square is 18t. Derivative of t square is 2t. So 9 into 2t is 18t plus 12. So plus 12. So here we get v and a in terms of t. So we have s, v and t. Sorry, s, v and a all are function of t. So if we know t, or if we have a particular value of t, we can get s, v and a at that particular time. Here we are interested in velocity and acceleration. So we take t is equal to 1 second here in v and a. So here if we put v is equal to t is equal to 1 here in v, we have 9 into 1 plus 12 into 1 plus 5 is equal to 9 plus 12, 21 plus 5 is 26 unit. Here I have taken unit as a unit. It may be meter per second, or it may be kilometer per second, or it may be centimeter per second, depending on the unit of s. So it is a 16 unit. So at t is equal to 1 second, the velocity of this particle will be 26 either meter per second or kilometer per second, or it is centimeter per second, or it is meter per minute, or meter per hour, or kilometer per hour, whatever it is. So t is 1 second, so it will be either meter per second or centimeter per second. Now let us get the value of a. So here if we put t is equal to 1 in this equation, 18 into 1 plus 12, it is 30. So acceleration is 30 unit. So it is again meter per second square or centimeter per second square. That acceleration is there for t is equal to 1 second. So at t is equal to 1 second, the velocity is 16 and acceleration is 30. So unit. So we can get the velocity and acceleration at a particular moment of time using this concept. Here we are getting the derivative of s with respect to t, that is v, derivative of v with respect to t, that is a, and put the value of t for v to getting the v and a at a particular time. Now one more example. Let us get the v and a at t is equal to 2. Here there is another equation of motion of a moving object or a moving particle, and we are asked to find velocity and acceleration at t is equal to 2. So if we differentiate this with respect to t, we get v, that is ds by dt. So derivative of t cube is 3t square minus derivative of 3t square, that is minus 6t plus 4. Now if we differentiate this v, we get acceleration. So acceleration a is dv by dt, that is equal to derivative of 3t square is 6t minus 6. So here we got v and a in terms of t. Now we put the value of t in this equation, we get velocity and acceleration at t is equal to 2. So if we put t is equal to 2 here, we have 3t square minus 6t plus 4. If we put t in this equation, we have v is equal to 3 into 2 square is 4 minus 6 into 2 plus 4. So here we have v is equal to 4 unit. So 12 minus 12 is 0 plus 4 is 4. Acceleration A, if we put t is equal to 2 here, 6 into 2 minus 6, so it is 12 minus 6, so it is 6. So we have v is equal to 4 unit at t is equal to 2 second, and a is equal to 6 unit at t is equal to 2 second. So here in this example also we have find v, that is ds by dt, then we have find a, that is dv by dt, and put t is equal to 2 second to get the velocity and acceleration at t is equal to 2 second. So this way we can find the value of velocity, acceleration at a particular time from the equation of motion. Let us have one more example. Here equation of motion of a particle is t cube minus 5t square plus 3t plus 1. At what time is a time it will change its direction? So we are asked to find the time at which the function or a particle changes direction. As we know, whenever the particle changes direction, right, at that particular time the velocity becomes 0, because to change the direction its velocity should be equal to 0. So at the time where velocity becomes 0, it will change its direction. So ds by dt, let us find, that is v, that is equal to 3t square minus 10t plus 3. Derivative of t cube is 3t square minus derivative of 5t square is 10t, and derivative of 3t is 3. Derivative of 1 is 0, so it is derivative of 3t square, derivative of t cube minus 5t square plus 3t plus 1, that is 3t square minus 10t plus 3. Now this derivative is velocity. Now if this v becomes 0, we have, if v is equal to 0, we have change in direction. So if there is a change in direction of a particle, v should be equal to 0. So let us take v is equal to 0. When v is equal to 0, it will change the direction, so we will get that time. So if we put v is equal to 0 here, we have 3t square minus 10t plus 3 is equal to 0. If we factorize this, 3 into 3 is 9, so 2 factors of 9 is 9 and 1, their summation is 10. So we have 3t square minus 9t minus 1 plus 3. So if we take 3t common from these two terms, we have 3t into t minus 1, t minus 3. 3t minus 1 into t minus 3. These are two factors. So we get either t minus 3 is equal to 0, or we get t is equal to 1 by 3. So we got two value, t is equal to 3 and t is equal to 1 by 3 seconds. These are the time where v becomes 0. So what we can say, at this time the direction of the particle will change. So we can say at t is equal to 1 by 3 second and at t is equal to 3 second, the motion of direction of particle will change. because at that time velocity becomes 0. So this is the example where we are interested to find the time where the direction of particle changes. So in this way we can also find at what time the direction of the particle or a moving object changes. Now one more example. We have equation of motion of a particle, that is 3t cubed plus 6t square plus 5t plus 1. We are interested to find its initial velocity. Now here, to find the initial velocity and acceleration, we should take t is equal to 0. So let us calculate this example here on Talitop. So we have S is equal to 3t cube plus 6t square plus 5t plus 1. This is equation of motion. What exactly we need? We need initial velocity and acceleration. So at starting point, what is the velocity of this particle and what is its acceleration at this? So first we'll find V, that is ds by dt. So if we differentiate this, we have 9t square plus 12t plus 5, and derivative of 1 is 0. So derivative of t cube is 3t square into 3 is 9. Derivative of t square is 2t, so 6 into 2 is 12t. Derivative of 5 into t is 1, so it is 5, and derivative of 1. So this is v. Then we get acceleration, that is dv by dt. So here, if we differentiate this function once again with respect to t, we have 18t plus 12, 9t square. Derivative of 9t square is 18t, and derivative of t is 1, so 12 into 1 is 3. Derivative of 5 is 0, so this is acceleration. Now initially, what is velocity and acceleration we want to know. So initially we have time is equal to 0. At initially time is 0. So if we take t is equal to 0 second, in this we get initial velocity. So for that, let us put t is equal to 0 here. So if we put t is equal to 0, we have 9 into 0 plus 12 into 0 plus 5. So it is 5. It is 5. So I can say unit. So initially the velocity of particle is 5 unit. Now initially its acceleration, if we put t is equal to 0 here, we get 18 into 0 plus 12, so it is 12 unit. That is its acceleration initially. So initially it has acceleration a is equal to 12. So this way we get initial velocity and initial acceleration of a moving object whose equation of motion is given. So this way you can find a velocity and acceleration at particular point of time, or you can get at what time it can change its direction, or you can check what is its initial velocity or initial acceleration. This way you can find different information regarding velocity and acceleration, or its displacement or distance covered by that object in using this concept. Have one more example of this. Here we are given an equation of motion of a particle that is s is equal to t cube plus 3t. We are interested to find at what time velocity and acceleration becomes equal. So we are interested to find at what point velocity and acceleration will become same. So if we have s is equal to t cube plus 3t, if we differentiate this function, we get v, that is ds by dt, that is 3t square plus 3. Now acceleration a, as we know, is dv by dt. So again we differentiate this function, will give 6t plus derivative of 3 is 0. So we got v and a. Now what is the condition given? We are given that what time velocity and acceleration becomes equal. So we compare these two, v and a. We are interested to find the time at which these two becomes equal. So let us put the value of t, that is 3t square plus 3, and put the value of a, that is 6t. Now 3 is common from both sides, so if we take and cancel it out, we have t square plus 1 is equal to 2t. If we take 2t on opposite side, we have t square minus 2t plus 1 is equal to 0. This is a perfect square of t minus 1 square. So what it shows, that at t is equal to 1 second, or at t is equal to 1, the velocity of a particle and acceleration will become equal. So if we put t is equal to 1 here, 3 into 1 plus 3, so it becomes 6, and here if we put t is equal to 1, it is 6. So we are getting t. There is no need to verify it, just sake of verification we have done. You don't need to do it, but we can verify that at this particular, means our answer is correct. T is equal to 1, we are getting velocity 6 and acceleration 6. So this is the way we can verify at what point we are getting the velocity and acceleration of any moving object, say. So here we are getting a different type of example where we are interested to change, to know where it changes its direction, what is its initial velocity or acceleration, or here, as we have seen, what time velocity and acceleration becomes same. So this is the example where we have seen at what time we are getting exact velocity and acceleration equal. Now one more example here. Equation of motion of a bullet fired is s is equal to 120 t minus 3600 t square. Find the distance traveled by bullet before it stops. So exactly we want to know how far the bullet will travel if we fire the bullet. That can be measured using mathematically this way. So it is a nice concept how we can, without a gun, you can measure this thing. It is a beauty of mathematics. So let us solve this example here. So we have s is equal to 120 t minus 3600 t square. This is equation of motion where which is satisfied by a bullet. Now we want to find what distance bullet has traveled before it stopped. So as the bullet stops, its velocity becomes 0. So at that point of time where bullet stops, velocity will be 0. At velocity, so we find the time at which v becomes 0. At that time, what distance bullet has covered can be obtained by substituting that value of t in the equation of s. That is, first we'll find derivative of s with respect to t. So it is 120 minus 7200 t. Derivative of t square is 2t. So 2 into 3600 is 7200. So this is the velocity of the bullet. Now we want how much distance bullet has covered. So at the time where bullet stops, v will become 0, velocity becomes 0. So what we are interested in? We are interested in finding out the time at which v becomes 0. So let us put v is equal to 0 here. So 120 minus 7200 t is equal to 0. It means 7200 t is equal to 120. So t is equal to 120 upon 7200 is 1 by 60 unit or second, you can say. So here what we are getting, in 1 by 60 second bullet has stopped, means that is the distance, means the distance covered in 1 by 60 second is required. So let us put t is equal to 1 by 60 in s. Let us take t is equal to 60 in s. So if you put t is equal to 1 by 60, we have 120 into 1 by 60 minus 3600 into 1 by 60 square. So this means if we cancel it out, it is 2 minus 60 square is 3600. So it is 3600 upon 3600. So it is 2 minus 1. So it is 1 unit. So the value of s is t is equal to 1 unit. What does it means? It means it has covered 1 unit of distance, whether it is meter or kilometer, it depends. So here we are interested to find the distance covered by a bullet fired from a gun. Now at the time where bullet stops, the maximum distance covered by it. So we have find v, substituted v is equal to 0. At that time the bullet reaches the maximum distance, and then that value of t we have substituted in s to get the distance. So this is the way by which the maximum distance covered can be obtained. Here let us have one more example of velocity and acceleration. So here equation of motion for a particle is t cube minus 6t square plus 9 t. find t and s when v is equal to 0. We want to find time and distance where velocity becomes 0. So in the same way we can find the derivative. S is equal to t cube minus 6t square plus 90. This is equation of motion, and we are interested to find t and s. T and s at v is equal to 0. So we put v is equal to 0 after finding v from this. That will give us t, and if we substitute that t in equation of motion, we get s. So let us do it. So v is equal to ds by dt. So this is 3t square minus 12t plus 9. So it is 3t square minus 12t plus 9 is velocity, where derivative of t cube is 3t square minus 6t square. Derivative of 6t square is 12t, and 9t is 9. Now we want to know at what time v is equal to 0. So let us put v is equal to 0 here. So that is 3t square minus 12t plus 9. So 3 is common from all this term. So it is t square minus 4t plus 3. If we take 3 common and cancel it out, we have t square minus 4t plus 9 or plus 3. Now if we get the factor of this, we have t minus 3 and t minus 1 is equal to 0. So means t is either 1 or t is equal to 3. So at t is equal to 1 second or t is equal to 3 seconds, the particle will stop. So we are having time at which the velocity becomes 0. Velocity becomes 0. So these are 2 times where the velocity becomes 0. So we got the answer for this. At what time v becomes 0? So these are 2 times, that is t is equal to 1 second and t is equal to 3 seconds, the particle stops. Now let us get the distance for this. So to get the distance, we put s is equal to 1 and s is equal to 3 in this equation. So if we put t is equal to 1, we have 1 cube minus 6 into 1 square plus 9 into 1. As we know, 1 cube and 1 square is 1, so it is 1 minus 6 plus 9 is 10 minus 6 is 4 unit. So at t is equal to 1 second, where the particle stop, the distance covered is 4 unit. So this is the first time where the particle stop, and at that time the distance covered is 4 unit. Now the particle also stop at t is equal to 3 seconds. So for that t, let us find s. So for that, let us put t is equal to 3 in s. So we have 3 cube, here t cube is 3 cube minus 6 into 3 plus 9 into 3. Here it is square, so square of 3. So what we have done, we have substituted the value of t in this equation. T cube minus 6 into 3 square plus 9. It is 27 minus 3 square is 9 into this 6 is 54 in plus it is 27. So at 27 plus 27 is 54 minus 54 is equal to 0 unit. So this is S is equal to 0. So what we can say, at S is equal to 0, again the particle will stop. So when V is equal to 0, so final conclusion, when V becomes 0, we have T is equal to 1 second, and at that time S is equal to, that is distance, is equal to 4 unit. And it also stop at T is equal to 3 seconds, and at that time S is equal to 0 unit. So it come back at the initial point at after 3 seconds. We can say the particle will come back at the same point from where it has started once again, and it will stop there. So this is the time and distance covered at V is equal to 0. So using this we can get some information about the particle or its motion. Here when V becomes 0, we have two time. At T is equal to 1, V becomes 0, means it changes its direction at that time, and after that V becomes 0 at T is equal to 3 seconds, and the distance also becomes 0. So we can say it will come to the initial point once again and it stops there. So it is a cyclic motion, you can say, or it is right terminated and initiated at the same point. So these are the conclusion we can get from the answer. Now one more example. Here we have taken 3, 4, 5 rather things together. We have taken an equation of motion, that is t cube minus 3t square, and we are asked to find when the particle will return to origin, means S is equal to 0, we have to find. Velocity we have to find at t is equal to 3. When it will stop, so we have to find when V becomes 0 and when its velocity will become 45 meter per second. That also we can find using this. We can find its velocity, certain velocity. Up to what time its acceleration remain negative. So these are 5 questions we have to answer for this. So let us one by one give the answer. The equation is t cube minus 3t square. This is the equation of motion. Let us find out V first, that is ds by dt. So it is 3t square minus 6t. Whenever we have such type of example, we find V and if necessary find A. So it is dV by dt. So we have 6t minus 6. So these are velocity and acceleration for the particle. Now let us give the reply of first question. The first question, when the particle will return to origin. So particle return to origin means when S becomes 0. Particle return to origin means when S becomes 0. So S becomes 0 means if we take S is equal to 0 here, we have t cube minus 3t square is equal to 0. So if we take t square common, we have t minus 3 is equal to 0. So we can say either t is equal to 0 or t is equal to 3 unit. But at t is equal to 0 means initially always it is at origin. So because it has not started its journey at this juncture, but we can say this is our answer. So after 3 seconds it will again reach to origin. After 3 seconds, or exactly after 3 seconds, it will reach the origin once again. So this is the answer for the first question, that at what time it will return to origin. So we can say at t is equal to 3 seconds or unit, it will reach once again to origin. Now second is velocity. We have to find the velocity at t is equal to 3. So we have to find v at t is equal to 3. So what exactly we need? We need velocity at t is equal to 3 seconds. So in v, let us put t is equal to 3. So 3 into t square is 9, that is 3 square, minus 6 into 3. So we have t square, t is 3, so 3 square is 9, and 6 into 3, it is 27 minus 18, so v is equal to 9 unit at t is equal to 3 seconds. At t is equal to 3 seconds. So this is the answer for second question. Now let us have the answer of third question, that is the when it will stop. So we have to get v is equal to 0, because at that time it will stop. So v is nothing but 3t square minus 6t. v is nothing but 3t square. So 3t square minus 6t is equal to 0. So if we take 3t common, we have t minus 2 is equal to 0. So we can say t is equal to 0. So at at 0 or t is equal to 2. But this we did not consider, because initially always velocity is 0 most of the case. So here t is equal to 2 seconds is our answer. So at this time velocity becomes 0. That is the answer of third question. Fourth question, when the velocity becomes 45 centimeter per second. This is value for v. This is value for v. So if we take v is equal to 45 in this equation, as we know v is equal to 3t square minus 6t. So 45 is equal to 3t square minus 6t. We have 3 common, so t square minus 2t minus 15 is equal to plus 15 is equal to 0. T square minus 2t plus 15. So we can have a factor of 5, so that t minus 5 we can get factor of this and get the value of t. That we leave for you. And the last is very important. When up to what time a will be negative. So 60 minus 6 is negative, means it is less than 0. This is a. So 60 is less than 6, so t is less than 1. So here for t less than 1, the acceleration is negative. After that, it becomes positive. So that is the answer of the sixth question that we have seen. So this way we can find the different aspect of the velocity and acceleration of the moving particle. This is second application we have seen. So you try to work out some more examples of this type, and this is all about differentiation. We have seen what is differentiation. We have seen various type of concept to get the derivative of different type of function. We have seen maxima and minima as a first application. We have seen second application, that is velocity and acceleration. So that is rate of change in one variable with respect to another variable. So there are so many concepts in engineering and technology where one quantity changes due to the change in another, where you can take use of differentiation. So please keep in mind that whenever you have change in one variable with respect to another variable, you can apply derivative. With this, let us end this session. Best of luck, and I hope this will help you a lot. You do more practice, you will get more success. Thank you.